Welcome back everybody. In this session we will discuss about FCFS scheduling and convoy effect. Right. So as we have discussed in the previous section, we have discussed about scheduling criterias, and we said that there are many scheduling algorithms. So we consider the scheduling criteria to select the best scheduling algorithm. So among all of them, very simplest one and the first one is FCFS scheduling. FCFS stands for first come, first serve. As you can see here, it stands for first come, first serve. It is very simple, right? So the process which arrives in the ready queue first, it will be served first. Like a queue. Queue will implement this rule: first come, first serve. FCFS. That's why this type of algorithm, FCFS scheduling, will be implemented by using a queue, right? So generally, what happens in a queue? There will be two things. Okay, one side is known as tail side, another side is known as head side, right? So processes will enter, or the things will enter into the queue from the tail side and move from the head side, right? The process which is at this head side will be served first. For example, consider initially P0 came from the tail side, P0 entered. Then after P0, consider P1 entered. Then after that P2 entered. So at the tail side we have P0. So P0 will be served first, right? So after that P0 will be removed from the queue, then P1 will be served. After that P2 will be served. So the P0 entered into the queue first, so P0 will be executed first. So this is the FCFS scheduling algorithm, and this can also be implemented by using a timer, right? In timer, what happens when the process enters into the ready queue, a time will be given. Okay, the for example here we have P0. For example, consider it entered into the system at 10 a.m. and P1 it entered into the system at 10:05, and P2, for example, it entered at the time of 10:10, right? So which is having the lower time, that is known as which came first. So in this example, P0 entered into the system first. Why? Because it is having lower amount of time. So this one will be serviced first, then P1 will be served, then P2 will be served. So this is the major concept of FCFS, right? First come, first serve, right? Regarding convoy effect, we will discuss after seeing one example. So before going to example, consider, okay, uh, consider what processes are there. For example, we have three processes: P0, P1, and P2, right? They are having arrival time as well as burst time. So arrival time tell at what time the process entered into the ready queue. For example, it entered at the 0th second, P1 entered at the, for example, 10th second, P2 entered at the time of 15th second in the ready queue. And they will have bus times also, right? So bus time, this is the time the process needs for execution. That is called as burst time, right? So for example, the bus times are very simple: 24, 3, 3, right? So among all these three, the first one entered into the queue is P0. So it was, this one will be serviced first, then P1 will be serviced, then P2 will be serviced, right? So P0 will be serviced for 24 seconds or 24 minutes, whatever you consider, and P1 is for 3 seconds, P2 will be done for 3 seconds, right? Okay, so see the how the scheduling will happen. So we consider a gnat chart for this. Okay, this is a gnat chart, right? Gnat chart will be like this. Okay, here a process the initially which process came? P naught came, right? So P naught will start the execution. Okay, it arrived at the 0th second. Okay, so it will do the execution for how much time? For 24 seconds it will execute. Okay, for 24 seconds it will execute. 0 to 24 seconds it will execute. Meanwhile, during this time P1 also came, P2 also came. So but they will not execute, they will wait for P0 to execute. Even though their bus time is only 3 seconds, they will wait for 24 seconds of P0, right? Okay, after that P1 will start the execution. Okay, it starts after P0 has finished, right? P0 finished at the 24th second, so P1 will start. It will do the execution for only 3 seconds. Why? Because it requires only 3 seconds. So when it will finish? Okay, after 24, after 3 seconds means 24 plus 3, at the 27th second it will finish the execution, right? So after this what we have? After this finally we have P2, right? P2 will start the execution after P1 finishes. So P1 finished at the 27th second. From the 27th second, so this process will start the execution. P2 will start the execution and it will execute for 3 seconds, right? So it will finish at what time? At the 27th second it started, and 3 minutes 3 seconds it is executing. So 27 plus 3, at the 30th second it will finish the execution, right? So now all processes have finished the execution, right? Now let us calculate their waiting time and turnaround time. Okay, so here only we will calculate on top here. Okay, the waiting time WT and turnaround time TT. So we have seen in the last class what is waiting time and what is turnaround time. So waiting time is the time during which the process is waiting into the ready queue for execution, right? Okay, see, P naught entered into the ready queue at the 0th second, so it is not waiting. At the same time it is starting the execution, so its waiting time is 0, right? P1 entered into the ready queue at the 3rd second and starting the execution at the 24th second. So waiting time will be the its starting of execution time 24, right? And when it entered into the ready queue at the 3rd second, right? So 24 minus 3, that is, it will wait for 21 seconds. Okay, and P2 started execution at the 27th second, and it also had, okay, wait. Okay, sorry. So sorry, here P1, this is not, it's not the waiting time of this. Okay, so this is P1, right? P1 started the execution at the 24th second and it entered into the ready queue at the 10th second, right? Okay, so during this time, first 10 seconds P1 was not there. P1 entered into that at the 10th second, right? So its waiting time will be 14 seconds. Okay, after that P2 started the execution at the 27th second and it also entered into the system in the ready queue at the 10th second. So its waiting time is 17 seconds, right? Okay, turnaround time when they are finishing, the finishing of execution is known as turnaround time, right? So P0 finishes the execution at the 24th second, and P1 finishes at the 27th second, and P2 finishes at the 30th second, right? So for a difference we make a table like this. Okay, right? So now if you calculate average waiting times, right? So how to calculate average waiting time? P0's average waiting time Okay, now we tell it as average waiting time, AWT, right, equal to what is this, 0 plus 14 for P1 and 17 for P2, right? So divided by total number of processes. How many we have? We have 3 processes. So how much we will get? We will get 28, 31. 31 by 3 means nearly 10. 10 point something we will get. Consider 10 seconds is the waiting time, right? Okay. So this is about the FCFS scheduling and average waiting time. So average waiting time is higher here. And coming to convoy effect. Convoy effect means the smallest processes will wait for the longer processes to finish the execution. If you see P1, it requires only 3 seconds of bus time, but it will wait for P1 to finish the execution 24 seconds. It will wait. How much time it is waiting? It is waiting for 10 seconds. It is waiting in the ready queue to complete the execution. Okay, same like that, P2 is also waiting for the long time, even though they require only very less time. Okay, this is known as convoy effect, right? So shorter bus time process will wait for long time, okay, for completion of longer bus time processes. This is called as convoy effect. To overcome this, we are having another scheduling algorithm known as shortest job first. Shortest job first. In this, what we will do, the process which will have less bus time, that will be executed first. More detailedly regarding this SJF algorithm, we will discuss in the next class, right? So coming to the drawback, as I said, here it will have higher waiting time, right? If you shuffle the order of execution, if we shuffle the order of execution, okay, then it may be the waiting time may be somewhat different. For example, consider here we will not we are not going to consider where the arrival time here, for example. Okay, okay, right. For example, consider the processes have arrived in this order: P2, okay, P3 and P1. In this order, the processes have arrived. Now let us calculate what will be the waiting time, right? Okay, same we will take here. Consider here we have the graph here, mat chart we have. Okay, what we are telling, P2 entered into the system first. So P2, right? So don't consider the arrival times here. Here we are considering only the order, right? So P2 entered into the system first. So it requires the bus time of, okay, same bus times you take here. Again I am writing bus time of P2 is, for example, how much? Okay, 3, right? So 3, and for P1, 24 seconds, right? Okay. See here, P2 will start the execution first. So 3 seconds it requires. So 0 to 3 seconds, it will finish the execution, right? So after that, who will start the execution? After P2, P3 will start the execution. Okay. At the third second, it will start the execution and it will execute for 3 seconds. Why? Because its burst time is 3 seconds, right? So when it will finish the execution, at the 6th second it will finish. So finally P1 will start the execution. P1 will start the execution for 24 seconds. It will do the execution. So means it starts at the 6th second for 24 seconds means Okay, for 24 seconds means 6 plus 24. At the 30th second, it will finish the execution. Right? Now, if you calculate the average waiting times, okay, waiting time of P2, P3, P1, right? What is the waiting time of P2? The waiting time of P2 is 0. At the 0th second, it is starting the execution, right? The waiting time of P3 is, when it is starting the execution, 3. Here we are not considering the time of arrival. We are considering the order here. Okay. And P1, it is starting the execution at the 6th second. Right? The average waiting time will be what? Okay. 0 plus 3 plus 6 whole divided by 3. Right? So the average waiting time will be 3 here. See what happened here? Okay. When we change the order, the average waiting time is reduced. The average waiting time is reduced, right? So as you can see, previously the average waiting time what we got is 10, and when we change the order, the average waiting time what we are getting is 3, right? So this is the drawback of FCFS scheduling. When convoy effect is there, the waiting time will be very high. Okay, and when we change the order, as you see, okay, here there is no convoy effect. The smallest processes are executing first. Okay, in the waiting time, average waiting time is also reduced. Okay, previously the average waiting time was 10, now the average waiting time is 3, right? This is about the FCFS scheduling, first come first serve scheduling. In briefly, in this scheduling algorithm, what happens? The process which entered into the ready queue first, that one will be serviced first, right? Coming to convoy effect, the longer process will if the longer process executes first, the smaller processes, the smaller bus time process has to wait. This is called as convoy. The drawback of FCFS scheduling is it will have higher waiting time, right? Regarding the remaining scheduling algorithms, we will discuss in our coming lectures. So kindly stay tuned. Thank you.